Hello everybody, welcome into another lesson. So today we are going to start our inequalities unit. And for the next little bit, inequalities are going to be very big in this course. So since this is Algebra 1, I am going to assume that all of you are familiar with A is less than B, A equals B, and A is greater than B. That A is some arbitrary number that's less than some other arbitrary number B, or you could have A and B are equal, them being the same number, or some arbitrary number A is greater than some arbitrary number B. By now you've all seen the symbolism. So there is a property of mathematics here that is introduced here in algebra, but it's very highly used in geometry. Once we get to geometry, you will definitely see why that is. But it works like this. Number one, let's say if you have A equal to B, right? So you have some arbitrary number A which is equal to B. They're the same number, and then it turns out that B is also equal to C, yet another number. That means A equals C. So if A equals B and B equals C, well then A equals C. That is the transitive property. Largely you'll use it for step 1 here in geometry to prove equalities. That along with the substitution property. That's the transitive, which borrows the substitution property. If A equals B and B equals C, well, since A and B are equal, you could substitute A in place of B and get A equal to C. So also the substitution property would also apply there. That's another big one used in geometry. But the transitive property also works with inequalities. If you have some arbitrary number A that's less than B, and that B is less than some other arbitrary number C, that means that A is going to be less than C. And then last but not least, if you have some arbitrary number A that's greater than B, and you have that arbitrary number B that's greater than C, that means A is greater than C. So it's kind of a 3-step process, the transitive property. Now when we get into geometry, we're also going to talk about 2 other properties. We'll talk about the reflexive property and the symmetric property. But for now, the transitive will suffice. I'm going to introduce a couple other properties. So this one here will be the addition property of order. This is called the addition property of order. So let's say if A equals B, what this addition property of order stating, if A equals B, then A plus some random number C is equal to B plus some random number C. So if A equals B, then A plus C is equal to B plus C. Well, how do we get that? Well, C definitely equals C, right? And A equals B, so it's the same number plus the same number. So that makes sense. Now, it also works that if A is less than B, then A plus some number C is less than B plus some number C. Well, that makes sense, because if you subtract C from both sides, since they're the same number, you'll end up just with A is less than B. Because C equals C any day of the week. So, yeah. So if A is less than B, then A plus C is less than B plus C. And then, you guessed it, the third one, if A is greater than B, then A plus C is greater than B plus C. So that also makes sense because C equals C, so you can subtract C from both sides, you would get back to A is greater than B. So that's how the addition property of order works. Now, there is also a multiplication property of order. So let's write this down real quick. Let's do the multiplication property of order. Alright, multiplication property of order. So if A equals B, that means that AC equals BC. So if A equals B, you could take that A times some arbitrary number C, set that equal to B times the same C arbitrary number. And if you divide both by C, since they're the same number, divide both sides, you'll get back to A equals B. And then if A is less than B, that means AC is less than BC. So yes, you may have some number A times some arbitrary number C less than B times some arbitrary number C. Excuse me. So it works on the less than, then you guessed on the greater than. If A is greater than B, then AC is greater than BC. So you can divide both sides by C, you'll get back to A is greater than B, since C equals C. So those are some properties of order. Those are useful properties to know. They'll help you more in the, really if you have to do proofs or in the theory department, that'll help you. It does come into play a little bit in the math part, but that's getting more into theory at that point. Now at this point I'm going to introduce some inequality equations. So here's what we're going to do. We're going to solve the inequality and graph the result. Okay. So we're about to solve the inequality and graph the result. So I'm going to show you what we mean here. So number one, we have n minus 4 is greater than 11. So we have n minus 4 is greater than 11. Well, if we're going to solve the inequality, this is more like a pre-algebra type of problem, really. So you may be thinking, gee, this seems easy. Well, it's worth reviewing, though, okay? If we recall from pre-algebra, to solve an inequality, you pretty much solve it like an equality. Pretty much like a regular math problem, like an equals, only you have a greater than sign instead of an equals. You want to get the variable by itself on one side, and then get the number by itself on another. Well, we have n minus 4, we just want to get n by itself, so we got to add 4 to both sides, because what you do to one side, you got to do to the other. So if we add 4 to the left side, you do get n by itself. That'll be greater than 11 plus 4, which is 15. So the answer to this, when we solve the inequality, is n is greater than 15. And if you want to check your work, put in any number that's bigger than 15, like 16. If you put in 15 itself, you'll get a false statement. You would get 11 is greater than 11, which isn't true. It tells you n is greater than 15, so any number bigger than 15, like 16. 16 minus 4 would be 12, that would be greater than 11, that's true. So, the last part of this was to graph it, okay? When you graph an inequality, you draw a number line, basically, alright? I'm going to put 15 in the middle. We'll do 14 next to it. You want to have a good few representative numbers. That's what you want. Let's see. 16, 17, 18. Okay. So we have a good number line here with 13 through 18. I have 15 roughly in the middle. To show something is greater than, just greater than. Now, if it were greater than or equal to 15, it'd be a little bit different. If it's greater than, you're going to put an open parenthesis facing to the right. If it's greater than, it's an open parenthesis facing to the right, and then you'll shade the entire region to the right of that. You would shade the entire region to the right of that to denote that it's just greater than. So n is greater than 15. You put an open parenthesis that faces to the right. Since it's greater than, you just shade the rest of the region all the way to the end of the number line. So that's really all you do to solve and graph these inequalities. But I do have more examples here. I'm not going to drop you off here. How about a plus 3 is less than 11? So this time we have a plus 3 is less than 11. Well, again, to solve the initial inequality, you're going to treat it like you would if it were a plus 3 equals 11. You're going to want to get a by itself, so you subtract 3 from each side. You subtract 3 from the left side, you'll just get a by itself. That'll be less than 11 minus 3, which is 8. So the answer to this is going to be a is less than 8. That would be the answer to this inequality. Now, if you want to check your work, put in any number that's less than 8. If you put in 8 itself, you would get a false statement. You would have 11 less than 11. We know that's not true. So if I put in 7, 7 plus 3 is 10, that's less than 11. That's a true statement. So a is less than 8. That's a true statement. All right. Last but not least, we must graph this. So again, draw yourself a number line. All right. Put the number it's less than roughly in the middle. And then draw some numbers to the left. Put some to the right. Just so you have a good representative sample. So, a is less than 8. If it's less than 8, you're going to put an open parenthesis, but you want that open parenthesis to face all the numbers smaller than 8. So you're going to draw it like that. The fat part of the parenthesis will bend to the right. Okay, so the open part's going to face all numbers smaller than 8. Then guess what? You're going to shade the entire region too. You'll shade the entire number line region, and you'll have your graph of a is less than 8. So far that's all you do for simple greater than or equal to. Now, we're going to get into some problems here pretty soon that have greater than or equal to or less than or equal to. I'll show you how to graph that in a minute. But here's an interesting problem. We have negative y over 2 is greater than 4. So we got negative y over 2 is greater than 4. Well, ultimately we want to just solve for y, don't we? Get it by itself? Okay. First, I think we need to multiply both sides by 2. Get rid of that denominator. If we do that, multiply both sides by 2, what you truly get is negative y is greater than 8. So you get negative y is greater than 8. Now, we want to just get y. We have negative y. We got to divide both sides by negative 1 in order to get y by itself, right? So divide the left side by negative 1, you get y. Divide the right side by negative 1, you get negative 8. Now, something interesting occurs though. Whenever you multiply or divide an inequality by a negative sign, it flips the sign. So once you've introduced a negative, you divide or multiply by a negative, that greater than sign is going to flip to a less than sign. So your real answer is going to be y is less than negative 8. That would be your answer. Y is less than negative 8. So if you don't believe me, let's test it. Let's say, so we have y is less than negative 8. What if we put in what if we put in negative 10? Any value less than negative 8. So we put in negative 10 as a y value. Well, you'd have negative of negative 10, which would be positive 10 over 2, which is 5. 5 is greater than 4. You can test it in the original inequality. So, again, whenever you multiply or divide an inequality by a negative, it flips the sign that you were working with. Y is less than negative 8. Now, we simply need to graph this. So draw yourself a happy little number line. Put that negative 8 in the middle roughly. Draw a good couple representative sample numbers. Whoops, I'm going negative. I need to go the opposite way. Negative 9 would come after negative 8. Then negative 10. Alright, so here we'll put negative 7 and negative 6. I think that'll be good enough. So we got our number line here. We want to show that y is less than negative 8. Since it's just less than, you're going to want an open parenthesis where the open part faces all numbers less than negative 8 on the negative 8. So right at the negative 8, I'll put an open parenthesis where the open part faces all numbers smaller than negative 8. Then I'll shade that entire region too, to the left of it. And that would be how I graph said solution. So I know inequalities at first can be a bit wonky to work with, but they're really not that bad. They just have a couple more rules than equalities, but okay. What if here we have 4q is less than 12? So we have the problem 4q is less than 12. Well, what we have to do to get q by itself is, again, divide both sides by 4. So if we divide the left side by 4, you'll get q. And then divide the right side by 4, you'll get 3. So you'll still get q is less than 3. And we don't need to flip the sign because we didn't have any negatives in play. So you'll just simply get q is less than 3. And then the final part of this is, well, to graph it. Draw a nice little number line here. Put 3 in the middle. I'll do 2 here, 1 here. Let's do 4 beside it, and then we'll do 5. Okay. So q is less than 3. So at 3 on your number line, you'll put an open parenthesis, but since it's less than 3, the open part of the parenthesis should face all numbers smaller than 3. So you'll draw your parenthesis like that, and then you'll shade the entire region that's smaller than 3. And that's how you would graph the solution. Alright, next. Oh, good one. We have 36 is less than x over negative 9. Well, what do we notice right away before anything? We have it reversed where the number's on the left and the variable's on the right. You want to flip that. You obviously want to flip that. You would like to have the variable on the left and the number on the right. Well, if 36 is less than x divided by negative 9, that can only mean that x divided by negative 9 is greater than 36. So we'll have x divided by negative 9 is greater than 36. All right. Now, we want to just get x by itself, right? We have a denominator of negative 9. Well, we need to multiply both sides by negative 9 in order to get rid of that denominator. You multiply the left side by negative 9, you'll just simply get x. Multiply the right side by negative 9. This is where it gets fun. So you'll take 36 times negative 9. That'll give you negative 324. But you multiplied both sides by a negative. So since there was a negative involved, it's going to flip that greater than sign into a less than sign. So you'll actually end up getting that x is less than negative 324. So yeah, x is less than negative 324. Now all there is to do is graph it. Put that negative 324 in the middle. We'll do negative 325 here. I'll put negative 326 here. Negative 323 here. And we'll go with negative 322 here. All right. So I have negative 324 in the middle. Since x is less than negative 324, what I need to do is put an open parenthesis where the open part faces the numbers less than negative 324. So it's going to go that way. Then I'm going to shade the entire region for all the numbers smaller than negative 324. All right. Okay, we have negative 6 is greater than s over 3. So we have negative 6 is greater than s over 3. Well, just like the last problem, we should notice right away the number is on the left, the variable is on the right. We don't want to see that. We certainly don't want to see that. We want the variable on the left and the number on the right. So we got to flip this. It would stand that if negative 6 is greater than s over 3, that would have to mean that s over 3 is less than negative 6. So we got s over 3 is less than negative 6. Now, we have s over 3. We simply just want to get s. So you got to multiply both sides by 3. If you do that, you'll get s is less than negative 6 times 3, negative 18. So s would be less than negative 18. And we did not need to flip the sign because we multiplied both sides by a positive number. So that keeps the sign intact. So s is less than negative 18. That's going to be your answer for this. Then we need to go ahead again and graph our result. So I will graph it. Put negative 18 in the middle. We'll do negative 19 next. Do negative 20 right about there. That should be good. Do negative 17 here. Negative 16 here. Negative 15 here. Alright, so s is less than negative 18. If it's just less than, at the point negative 18, you will draw an open parenthesis where the open part of the parenthesis faces all numbers to the left of negative 18 or smaller than negative 18. So you're going to put the open parenthesis at negative 18 facing all numbers smaller than negative 18, then shade the region to the left of negative 18. And that would be how you graph the solution. So that wasn't too terrible either. Alright, what's next here? Oh, good one. Negative 6m is greater than or equal to 6. So now we're seeing negative 6m is greater than or equal to 6. Well, this is a little bit different since we have greater than or equal to. It's not simply just greater than anymore. The result's going to be greater than or equal to 6. So, you're still going to solve this like any other inequality. We want to get the m by itself, right? So we got to divide both sides by negative 6. Divide the m by negative 6, you do get m by itself. Divide positive 6 by negative 6, you get negative 1. But just like you would if it were greater than, since you divided both sides by a negative number, it's going to flip that greater than or equal to sign into a less than or equal to sign. So what you're actually going to get is that m is less than or equal to negative 1. That would be your answer. Then we got to graph it. Well, how do you graph greater or a less than or equal to? So it's not too different. We'll put the negative 1 in the middle. And let's do negative 2, negative 3. We'll do 0, positive 1, and positive 2. Okay. So if it's got an equal component to the sign, if it's less than or equal, this time instead of a parenthesis, since it's got the equal part, you're going to draw a bracket at that point. You draw an open bracket where the open part of the bracket faces all numbers smaller than negative 1. So you'll put a bracket there, and then you'll shade the entire region to the left of that number. So instead of a parenthesis, you put a bracket whenever it's got the equal component to it. But the open part's still facing all numbers smaller than negative 1. So it's similar but different when you have the equal component to an inequality. Alright. Negative 5w is less than or equal to 15. So we have negative 5w is less than or equal to 15. Well, of course the goal is get w by itself and solve this inequality. We have to divide both sides by negative 5. You divide the left side by negative 5, you do in fact get w by itself. You divide 15 by negative 5, you get negative 3. But you divided both sides by a negative, therefore it's going to flip that sign. The original sign was less than or equal to, it's about to become greater than or equal to. So the actual answer you will get is w is greater than or equal to negative 3. So w is greater than or equal to negative 3. Now we need to graph it on a number line. So I'll put negative 3 roughly in the middle, negative 4, negative 5, alright, let's see here, negative 2, negative 1, then 0. Alright, so we have w is greater than or equal to negative 3. So if it's greater than or equal to negative 3, you're still going to, it's got the equal component, a bracket will go at negative 3. But since there's the greater than component, the open part of the bracket at negative 3 will face towards all numbers bigger than negative 3. So here's how the bracket's going to look since it's all numbers bigger than negative 3. So you put the bracket, then you shade the entire region going from negative 3 to the right this time, since it's all numbers greater than negative 3. So that's how you would graph w is greater than or equal to negative 3. All right, what's next? Let's see, we have x over 2 minus 4 is greater than negative 6. So we got the problem here, x over 2 minus 4 is greater than negative 6. Well, I think we should start by getting the x over 2 by itself, right? In order to do that, you have minus 4, you need to add 4 to both sides. So we add 4 to the left side, you'll just simply get x over 2. That'll be greater than negative 6 plus 4, that's negative 2. So now you got x over 2 is greater than negative 2. Then ultimately we want to get x by itself, so you got to multiply both sides by 2. Multiply the left side by 2, you just get x. That'll be greater than negative 2 times 2, which is negative 4. So you end up getting x is greater than negative 4. And you don't have to flip the sign since you multiplied both sides by a positive number. So you end up getting x is greater than negative 4 for your answer. So let's go ahead and graph it. I want to get you used to graphing these two because you go take a lot of math courses, they're going to have you graph them. So let's put negative 4 roughly in the middle, negative 5, negative 6, negative 7, negative 3, negative 2, and I think negative 1. That should do it. Okay. So we want to just, this time it's just x is greater than negative 4. There's no equal component, just x is greater than negative 4. If it's just greater than, it's going to be a parenthesis. It'll be an open parenthesis at negative 4 with all, where the open part faces all numbers bigger than negative 4. So the parenthesis is going to look a lot like that, facing to all numbers greater than negative 4. Then you'll just shade the entire region to the right. And that's how you would graph that x is greater than negative 4. All right. Let's see here. I want to do a couple more. There's a couple more I'd like to do, then we can call it good. Negative 4. So we have negative 4 is greater than or equal to 4 minus u over 2. So that one looks like a mess. We have negative 4 is greater than or equal to 4 minus u over 2. Again, we have these switched around from how they need to be. We need to get the variable on the left-hand side, put the regular number on the right. So it would stand to reason that if negative 4 is greater than or equal to 4 minus u over 2, that means 4 minus u over 2 is actually going to be less than or equal to negative 4. So that's how we restore the proper order. Now, ultimately, we want to start by getting that negative u over 2 by itself, do we not? So we have a plus 4 on the left side. That means we actually need to subtract 4 from both sides in order to get that negative u over 2 by itself. So let's go ahead and do just that. Subtract 4 from the left, you'll end up getting negative u over 2 by itself. That'll be less than or equal to negative 4 minus 4, that's negative 8. So you end up having negative u over 2 is less than or equal to negative 8. Well, I think let's start here by multiplying both sides by 2, right? We want to get rid of that denominator of 2, so we got to multiply both sides by 2. If we do that, you'll get negative u is less than or equal to negative 16. Now, we have negative u, we need to get positive u on the left. So that means we have to divide both sides by negative 1. Divide the left side by negative 1, you just get u. Divide negative 16 by negative 1, you get positive 16. But since you divided both sides by a negative, it's going to flip that less than or equal to sign into a greater than or equal to sign. So your real true answer is you're going to get u is greater than or equal to 16. So yes, that's what you would get. U is greater than or equal to 16. And last but not least, we will go ahead and graph this. So let's go ahead and draw our number line, put 16 in the middle. So we'll have 15 to the left, then 14. All right, 17 to the right, 18, let's draw 19 even. Okay. So u is greater than or equal to 16. So since there's the equal component, you're going to draw a bracket at 16. But since it's got the greater than component, that bracket at 16 is going to face all numbers greater than 16. So let's go ahead and put that bracket there. Then we'll shade the entire region of all numbers greater than 16. And that would be your answer. That'd be how you graph it. Okay, I got one more problem, then we'll be done for the day. Oh, good one. So we have 4 times 2 minus v is greater than or equal to the negative of v minus 5. Alright, so we have a couple distributives here. We have 4 times the quantity of 2 minus v is greater than or equal to negative of v minus 5. So, what we're going to have to do here, like you would for a normal equality problem, is do your distributive property. So, you'll take 4 times 2, that's going to give you 8 minus 4v. You'll have 8 minus 4v is greater than or equal to negative of v, that's negative v minus minus 5, well that's plus 5. So what you would end up getting is 8 minus 4v is greater than or equal to negative v plus 5. Well, I think first, let's deal with the left side. Let's get that negative 4v by itself. So you gotta subtract 8, right? So if you subtract 8 from the left-hand side, you'll just get simply negative 4v is greater than or equal to negative v. Then you have plus 5 minus 8, that's minus 3. So you'll end up getting negative 4v is greater than or equal to negative v minus 3. So that's one component. Now we want to get that negative v out of the right-hand side, don't we? We want to just get that negative 3 by itself, right? Okay, what you need to do now is simply add v to both sides. If you add v to the left side, negative 4v plus v, that would give you negative 3v. That would be greater than or equal to negative v plus v is 0, you just have negative 3. So now you're reduced down to negative 3v is greater than or equal to negative 3. And then, of course, we want to just get v by itself, so you got to divide both sides by negative 3. You divide the left side by negative 3, you'll get v. divide the right side by negative 3, you'll get positive 1. But since you divided both sides by a negative number, it's going to flip that greater than or equal to sign into a less than or equal to sign. So the real result for this you'll get is v is less than or equal to 1. So let's see, 4 times 2 minus 1, that's going to be 1, that'd be 4. You got 1 minus 5, it's negative 4. Yeah, 4. Okay, so that would actually check out. V is less than or equal to 1. I was just kind of checking my work for a minute. If you're ever unsure, feel free to check your work. Alright, then last but not least, we are tasked with graphing this. V is less than or equal to 1. So put 1 in the middle. We'll do 0. Negative 1, we'll put a negative 2 there, positive 2, positive 3, positive 4. I think that's good enough. Okay, so we have 1 right here in the middle. V is less than or equal to 1. So since there is an equal component to this inequality, you'll put a bracket at 1. But since there's the less than component, you're going to make the open part of the bracket face all numbers less than 1. So how it's going to work is like this. The open part of the bracket will face all numbers less than 1. Then you'll simply shade all numbers less than 1. So yeah, that's all there would be to graphing these inequalities. So that's it for basic inequalities. Next lesson, we're going to get into a little bit of number theory. We're going to talk about intersections and unions of sets. So I hope everybody has a good night. Take care.